Alright, David Can here with another question from your Hayes and Harris Math SL textbook. This is exercise 8b, question 12. In this question, we're dealing with a sheep on a tether attached to a post in the ground. This is near a fence that the sheep can't get across. The post is 6 meters away from the fence, and the tether is 9 meters long. 6 meters and 9 meters. I want to find the area which is available for the sheep to feed on. So first off, let's draw onto this diagram the space that the sheep can reach. So we're going to add a circle, starting at the post, going outwards, and this represents the region that the sheep can reach. Oops. So the sheep attached to the rope can only get as far as this circle, but also not across the fence. So they can't reach this space. There's a couple of key things in here, such as the distance from the post to the fence and the intersection of that region, and the same on the other side. Now these two lines are radiuses of the circle that the sheep can reach, and that's the length of the tether. That's 9 meters each. And so ultimately what we want to know is, what's the area of this circular shape minus the section on top? There's a number of ways to solve this kind of question, but we don't have a whole lot of tools at our disposal. We only know about sectors and segments. So we're going to have to approach this in a careful way. There is a giant sector here that we can try and find the area of if we knew things like the angle in here. So that's one thing we're going to want to try and find. That's also going to leave a triangle that we'll have to find the area of, but that's also something that we can do. First, let's work with this triangle in here. I'm going to redraw it over here. That's 9 meters, 9 meters, and 6 meters down the center. Because this is tangent to this line, I know that's a right angle, and that's a right angle. And that right angle is going to help me out a lot. It's going to allow me to use some trigonometric identities, and it's also going to allow me to use Pythagorean theorem to say, find this length here, x. First off, let's go for that length x. X squared, using Pythagorean theorem, plus 6 squared has to equal 9 squared. Hypotenuse squared is side squared plus side squared. From this I can get the length x, which is also this length x, by the way. Solving this for x squared, I get x squared is 9 squared, 81. Take away 6 squared, 36. That means x is the square root of 45. Anytime you take a square root, you need to remember plus or minus. You need to consider that. But here we're talking about a length, and the length isn't going to be negative. So we'll just leave this as positive square root of 45. Using this now, I'll be able to find the area of the triangle. I'll be able to find this area here. What remains is for me to find the area of this sector, this big Pac-Man looking up sector. To do that, I need this angle. Let's call it theta. Theta is going to come from this angle. Let's call it phi. That's this angle here, phi. So ultimately I need phi. I can get phi though because this is a right triangle, and I just need to remember so, ka, toa. I now have side, side, and hypotenuse, so I could use any sine, cosine, or tangent. I'm going to choose to use the 6 and the 9, because that's what was given to me originally, and that's going to help me avoid passing any errors forward if I made a mistake here. But if I'm doing things correctly, it shouldn't matter. So using 6 and 9, that's the hypotenuse and the adjacent side. That's the adjacent and hypotenuse. I want cosine. So the cosine of my angle phi is equal to adjacent 6 over hypotenuse 9. Solving this for phi, we have to move cosine to the other side. To do that, you have to take the inverse cosine of 6 on 9. And that's something you'll have to plug into your calculator to solve. But when you do, you want your result to be in radians, because we're usually working in radians when we deal with these sector problems. When you do, you'll find that theta should be 0.841 radians. Alright, that gives me phi. I want to use phi to get theta now. And that's not too bad, because that angle's phi, but so's that angle. And so I can say that the whole circle, 2 pi, is made up of theta and phi and phi. So the whole circle 2 pi is theta plus 2 lots of phi. Which means that theta is equal to 2 pi take away 2 phi. That's 2 pi take away 2 times 0.841 radians. You can plug that into your calculator if you like, and what you'll find is that theta has to be 4.98 radians. Alright, that's all the information we need to finally start looking for what we want, and that's the area here in blue plus the area here in green. That's the total area. So let's start with the area in green first. The area in green is going to be the sum of the areas of these two triangles. There's 2 of them, and the area of a triangle is 1/2 base times height. So that's the area of that triangle and the area of that triangle. Then we need the blue area. The blue area is the area of this sector. And that's going to be r theta. Oh, excuse me, 1/2 r squared theta. Okay. All of these things I know, so I can plug in and solve. The area then is 2 times 1/2 times the base of the triangle, that's x, that's the square root of 45, times the height, that's 6, plus 1/2 times the radius of the circle, that's 9, squared, times theta, which we calculated was 4.98 radians. Like we said, everything here is known, except for the total area. So all we have to do is plug all of this into our calculator and solve. The first term works out to 40.2, and the second term works out to 186.2, for a total area of 226.4 square meters for that sheep to eat.